Welcome to a screencast showing functions that have been developed in the IMES research project dealing with EAST-ADL functional models and their assignment to behavioral models in the form of block diagrams. In the system design process, before you even decide whether a function should be implemented in hard or in software, the system designers draft functional networks or functional models which have the logical functions that the system is made of without specifying software or hardware. While in the automotive industry for everything software, there is the pretty well-known AUTOSAR standard established in standardizing everything around the software development. For the earlier phases and aspects of safety, there is a lesser known standard called EAST-ADL, which helps in functional modeling and security and safety aspects. Now, the first thing that you have in the EAST-ADL model is function modeling, the function types, and with IMES we have implemented an editor for EAST-ADL functional model. So this is the prototypical editor, which is not yet finished. But you see, for example, that we have a very basic function model here, because the focus of the screencast is on showing the assignment to the behavioral models. And our function model has two functions. It has an engine, which has an input port, and it has a throttle as the system or the function that gives some data. Now these are functions that now can be used in one or more specific system. So for example, a system, we can model it as a larger function, and maybe this is, for example, some sedan type car that we want to model. And then in this system or subsystem, we want to use the engine and we want to use the throttle. And then let's show all the ports of the classes. So we have output ports and input ports. And then we can, for example, connect those ports to make up the system specification. Now, obviously in a real system, this would be much more complex, and there's a lot of functionality in layouting, etc. But today we want to discuss and demonstrate something else. So these are very abstract models of functional networks, and often even in early design process and in early design stages, the functionality is already specified by block flow diagrams, like they are provided by several tools, well-known tools, and we will show an integration and management of those diagrams and models within Eclipse. So what we are using is the DAMOS tooling to show the models that specify some behavior, but it could be any other artifact, any other tool, and any other model that can be integrated here. So for our engine analysis function, we might have some models that we would like to actually be associated with the actual engine function. So let's have a look. We have a completely irrelevant model here. It has nothing to do with engine control. It's just to show the tooling. So we have a more coarse-grained model here with only a few functions, and then we have a few other additional functions, so that we have two different kind of models. So what we would like to do is to actually make an association between the analysis function or the EAST-ADL function and its descriptions in the block diagram format. So what we do is we use the Eclipse tooling Yakindu, which is provided by IMES and has been adjusted to and configured to the IMES purpose here. And so now we would like to say, okay, assign the engine model to the actually function. So we pick the engine function, and we have to save the editor. So now we take the engine, and through the Yakindo Kramer facility, we are now building up the assignment to the model by saying we want to start with the engine. So we pick A, and you see that in the tracing editor here, that is taken as the start point, and then we want to assign it to a model. Have to go to the other explorer here and pick it as B, and then we configure the tracing so that we have different points of traces. Now we want to specify that this function in EAST-ADL represents our course diagram, and then we create the trace, and you see that it appears here. In the trace explorer, we see that the engine function is traced to the model, and otherwise we see how the model is being traced. So we set up another trace to the detailed diagram, and again create a represents. And so now we have the information that the engine is represented by several functional models. That information can be queried here in the Tracing Explorer. There's also facilities on doing reporting, and for example we have a tracing overview here where you can actually see a graphical representation of all the tracing relationships. And now, for example, in our Sedan diagram, we might pick one specific model for this use, and so this is still something where you have to do manual work. There will be more support in actually just simply picking the models assigned to the actual function. But now we would, for example, say, okay, this specific instance of the engine function should be, for example, the detailed, and we specify that it's actually being picked by using the instantiates as a trace type. And now you see that we have additional traces. We can use those and have actual queries on that in a later view. Okay, then also the tracing overview is adapted, and you can see that we find all the relationships here querying through the model. The tracing is actually not hard-coded. It is done with the Yakindo traceability. So we can see that if we open this with the configuration editor of Yakindo, then we see that we have different trace types here, for example, that we can add new types, specific types. We have endpoint types, and we can, for example, even add additional attributes depending on the user customization. So the next point is then to actually derive a model and a query to actually concatenate all the block diagrams that make up a specific configuration.